Hi everyone. So in today's video, let's talk about data ingestion. Okay, let's talk about what exactly is data ingestion and what are the examples of common data sources that we will be ingesting the data from in real world, and then we will also go through why ingestion matters in first place at all, and then we will understand what is naive data ingestion means and what is mature data ingestion means, and we'll try to understand what are the differences between naive data ingestion and mature data ingestion. And then as a final thing, we are going to kind of understand what are the important things or what are the key things that we need to consider before developing any kind of ingestion logic or before choosing any kind of technology or tool for doing the data ingestion. And then we are going to conclude today's video. Okay, so let's talk about it. Maybe before actually getting into details about what exactly is data ingestion, let me start with this small thought. Okay, so if you have ever wondered like why two companies can use same set of tools like Snowflake or Databricks or Kafka or Airflow or Azure Data Factory or data pipelines in Fabric, and yet like one company can end up having like really clean and reliable and trustworthy data, and while other company like might end up like struggling with late data pipelines or schema mismatches or missing data and and constant firefighting and all that. Okay, so I would say actually the difference itself is actually not in the tech stack alone. So it totally depends on how the data entered the system. Okay, so and normally that first touch point, right, the very first handshake between the real world or the data sources and the data platform, that first touch point is generally called as ingestion. Okay, so that's not the official definition of ingestion, but the first touch point, the first handshake between the the data sources and the and your data platform, that's basically called ingestion. Okay, whenever there will be the part where the data enters from data sources to your data platform, that first touch point is called ingestion. And normally here is the funny part, like most of the beginners, what they will do is they will tend to like completely ignore ingestion or pay a lot of attention to the whole process of ingestion, because for most of the people it unfortunately it feels simple, and it is simple in most cases, but that's not actually the case most of the time. Okay, so but if you actually ask a senior engineers, they will actually respect all this ingestion process and all the take on ingestion, because they have seen what happens in production, like when you treat ingestion as like some casual thing that you want to develop, right? So today, let's try to dig deep into data ingestion and let's understand what exactly is data ingestion, what are the examples for common data sources, and why ingestion matters. And then let's try to understand the differences, in approaches between naive and mature data ingestions. And then let's, conclude it by talking about key considerations. So, starting with the first one. Okay, let's start with the first one, which is what is exactly data ingestion. So if I have to like kind of give a textbook definition of data ingestion, so it is basically the process of collecting the data from one or more source systems and then moving it into the data platform for storage or processing and analysis. Okay, so if I have to define it, so ingestion is basically the process of collecting the data from one or more sources. Okay, it is the process of collecting the data from one or more sources and moving it into the data platform, that you are trying to build. Okay, for storage or processing, which also means like any kind of transformation logic, and and of course for any kind of analysis. Okay. So, so again, if I have to repeat what is data ingestion, um, data ingestion is basically the process of collecting the data from one or more source systems and moving it into the data platform for storage, processing, and analysis. So this is textbook definition, but I will try to add a little bit, little more to it. Okay, that is, I will say it is, of course, the process of collecting the data from one or more sources and then moving it into the data platform for storage, processing, and analysis. But then I will also say that in a so we should all do it in a reliable, okay, reliable way, consistent way, okay, and intentionally. This is actually the key point I want to highlight. So of course, data ingestion is a process of taking the data from source systems and then putting it into your data platform. But then I'm saying we should do it in a reliable, consistent, and most importantly, intentional way. Okay. So that's the important point here, intentional. Okay. So ingestion is not just like copy paste. Okay. It's a designing how data should arrive into the data platform. So to make this more meaningful, let's break ingestion into maybe like 3 layers. Okay. So let's talk about 3 different layers that you normally or commonly encounter in real world projects. Okay. So if we have to talk about layer, and also maybe what's the meaning of layer and what kind of question it answers. So let's talk about it. Okay. So normally you most frequently you will see 3 layers. Okay, when we talk about ingestion, so which is basically acquisition or data acquisition, and then data movement, and then you will also see something called as landing, right? So what these 3 layers kind of indicates is these are kind of like 3-step process. So here there will be your source systems, and then there will be your data platform on the other side. What you do in the middle kind of represents all these 3 layers. So first, in order to do data ingestion, which means like collecting the data and then put it into data platform, you kind of have to acquire the data and then move it from the data sources to your landing zone, which is in your data platform. Okay. So this is kind of the 3-layer approach we are talking about here. So yeah, again, if we had to talk about meaning of each layer, so I'm saying acquisition is basically getting the data from source, right? Acquisition is getting data from source. And movement, okay? Movement is transporting the data, right? And then the final one, landing. Landing means wherever it first sits in your data platform. Okay. So acquisition is getting the data from source. Movement is whatever the data we got, we should transport that to your data platform. And then landing is like a place in your data platform where your data arrives that you just acquired and tried to move it. Okay. So this is a 3-layer approach that we are talking about. And then we should basically, okay, these 3-layer approach kind of answers 3 different questions. Okay. So if we talk about acquisition, here one thing we need to answer is what kind of data we need, and then how do we extract it. So in this first layer, we need to know what kind of data we need and how do we extract it, right? See, because in the source system there can be like thousands of tables or a lot of different data points, but let's say if we are building some kind of analytics platform, we might not need to get all the data which is available in the source system, right? So because let's say we might be working in some kind of departments, like for example marketing or HR or finance or something like that, or economics or something like that, right? So we don't need maybe like all the different kind of data points or all the different transactions which are available in the source system. So that's why like before doing any kind of data ingestion, we need to ask ourselves some question as per the 3-layer approach. Okay, these are some of the basic questions that we need to first get it right. So that is, so for the acquisition layer, we need to know what kind of data we need and how do we extract it. Okay, and then for the movement layer, okay, or for the movement stage or for the movement phase, we need to kind of answer the question when does the data travel. When does the data travel, in the sense like how should we extract it, okay, and what time it is getting updated in the source, so that we need to kind of develop our ingestion logic or ingestion pipelines to fetch the data once it is available in the source, right? So yeah, we need to answer that kind of question about the movement layer. And then if we talk about the landing layer, okay, we need to know one more important question, which is where does it actually live in landing layer and in what format? Where does it live and in what or which format? It can be CSV or JSON or Avro or Parquet or it can be in different formats, like any format. Okay, and where does it actually going to live in landing? Because in landing you might have different landing zones for like different kind of source systems normally. So but where do you map it? So if it is source A, you need to kind of map it to the source A's landing zone. And then if it is source B, you need to map it to the source B's landing zone. So you're not supposed to like take the data from source B and then put it into source A's landing zone. So that is incorrect, right? So of course, if you don't have any landing zone, you kind of need to define how do you want to handle that and all that stuff. Okay, you kind of need to answer all these questions for these 3 layers or 3 phases that we talked about, which is acquisition and movement and landing. Okay, and then of course, like if any of these layers are like unclear for you or inconsistent, most of the time what ends up happening is like everything downstream kind of becomes like a little bit harder to handle. Okay, because ingestion is the one like which is kind of like connecting to sources and getting the data into your storage, right? So if ingestion itself is bottleneck, so how can you reliably run your data transformation logic or business logic or your serving part? So that's why it's really important to get ingestion right. And then so moving on to the next one. So next we are going to talk about examples of common data sources. Okay, so now let's talk about the common data sources that we are going that we normally see in like day-to-day real life or real world companies. So in the real world, normally ingestion rarely comes just from one source, right? So it usually comes from, if you are working in a company, you might of course relate to what I'm saying. So you might have observed that if you are already working in like data platform, you might be getting the data from different kind of sources. You might be getting some kind of customer data from I don't know, SAP, or if you might be getting some kind of other transactional data from operational databases, or you might be getting some other data from CRM systems, or all different kind of places. So or maybe like some streaming sources as well. So in the real world, so ingestion rarely comes just from one source. And And it normally happens like the data normally comes from different kind of sources, and then there are a lot of different source types which are available. So we are going to of course talk about what are some of the common source types that you normally see in day-to-day life, and then what are the examples for them in technology way, and then we are going to kind of a little bit also touch upon the characteristics of all the different kind of source systems, and then we are also going to talk a little bit about the challenges involved while getting the data from that source systems into your data platform. Okay, so let's start that. So let's talk about maybe let's make a table. um, so let's talk about like source type, what are the different source types, and then let's talk maybe let's give a little bit of examples for them, and then let's also talk about the characteristics of that sources. Yeah, and then also let's talk about the challenges involved while getting the data from that sources, right? So first and foremost, the most common data source that you will ever see wherever you go, irrespective of irrespective of the company you go. I don't know, it can be like Amazon or Microsoft or Google, or maybe some kind of banks, or some kind of consultancy companies, or some product companies, or it can be any company. Most of the time you will see traditional operational databases. Okay, so this is the most common type. So I can say that there might not be like not even one data engineer who would have never worked with operational databases or just relational databases, right? So I'm pretty sure that at least every data engineer, at least they will work with one of the traditional database at least once in their career. Okay, and then examples of these sources would be, for example, like it can be Postgres, or SQL Server, or it can be like MySQL, and of course everyone knows MySQL as well. So these are some of the examples of operational databases. Okay, and then so if you want to talk about the characteristics of operational databases, so these are actually really nice for frequent small writes. Okay, so if you are writing the data like frequently, which is like a record level, and then if it is like normalized, if you have normalized data model in place, and then if it is kind of transactional, then this is the way to go. Okay, and normally for all these kind of characteristics, so you will normally see operational databases in production systems in many companies. And then the challenge here is actually the challenge while getting the data from this kind of operational databases is basically avoiding or avoid overloading the systems. Okay, avoid overloading the systems in production actually, because so these are operational databases. Now what do I mean by operational databases is, so let's say if your company has an application, or if your company has some kind of product and which has like an application, so that application might be using the operational database as a storage, okay, for application storage. Or this operational database might also be getting used to support your companies or your products operations, right? So so if you are trying to kind of get or fire large amount of or huge heavy queries to get the data from these operational databases during work hours, then it is probably going to slow down your operational database, because it is peak hours, because in during the peak hours or work hours, you will be serving essentially the customers. Your customers are users, so you will be getting the let's say this is operational database, right? So there are your users or customers on one end who are making the request to the database, and then there is BI or analytics teams or data platform on other end. So let's say they are also making the request. So now there is suddenly contention, right? So, but who are priority? I would say users in most cases, okay? Because you always want to like provide the best service to the customers. If your customers are experiencing delay because of your internal workloads, then that's a problem, especially on the operational database. So here you should try to avoid overloading the production, okay? And then let's move on to the next common source type, that is SaaS applications. Okay, so SaaS applications, SaaS means basically software as a service, and here some of the examples I would say would be Salesforce, and then HubSpot, Shopify, and also Jira, for example. Okay, Salesforce, HubSpot, Shopify, and Jira. And of course, everyone might have heard about Jira or Salesforce at least. So, and it's totally fine. Like if you have never worked with SaaS applications, that's also totally fine. So these are, I'm just talking, I just wanted to talk about examples of common data sources that you'll normally get to ingest or collect the data from and then put it into the data platform. So, and most often it will just be operational databases or relational databases in most companies. But then the second most common one is also SaaS applications, which is like Salesforce, HubSpot, Shopify, and Jira. Okay, and here the most characteristics are basically it will be API based. Okay, and then so since it is API based, of course it is rate limited, and then of course it will be paginated as well. Yeah, so whenever you get into the whole concept of API, then you will kind of understand what is rate limiting and pagination. Um, again, so this video is not about like explaining all the different characteristics of API and all that stuff. I'll definitely for sure make a different video about APIs in general and what are the different kind of APIs and what is generally API means and all that. But this video is not for that. So let's keep it rolling. Okay, and then if we want to talk about the challenges involved while get the data from SaaS applications into your data platform, one of them would be schema drift. Okay, and then other one would be throttling. So throttling in the sense, if you try to make like too many requests to the API or to the SaaS application, then basically it will throttle. Okay, and schema drift is generally issue while fetching the data from many sources. If you have like bad logic or bad data pipeline design, so it can show up. But then also at the same time, it is recommended that your data changes over time, and then you should kind of accommodate it. Yeah, that's fine. But then you will also kind of see like or observe schema drift whenever you're dealing with any kind of API sources or just JSON databases in general, because JSON is kind of flexible, and then you can add like whatever the fields to it, and then it will just take in, and then once you try to ingest it, suddenly you will realize that the schema has been changed, and then our data pipeline is like breaking, and how do we handle it? So yeah, that's one of the major issue or major challenge that we need to address whenever we are talking about like data ingestion from SaaS applications to the data platform. Okay, and then moving on to the next common source, which is files. Okay, when I say files, it's just basically I'm talking about like any kind of delimited files like CSV or basically Excel or Parquet or any kind of thing, or etc. Basically, there are all different kind of file formats available, and then most of the time you will end up receiving these files through SFTP, or maybe in some companies on SharePoint or OneDrive or on some network drive as well. Okay, and then characteristics of these files would be most of the times you will be receiving the files as batch drops. So when I say batch drops, someone will be gathering the data and putting the data in some place, or you might also be receiving these files from nightly schedules. Okay, and then if you want to talk about the challenges involved, then it is actually mainly the formatting issue, inconsistent formatting. So here again, I'm saying like there can be more challenges than the ones which are listed here. Here I'm just listing the ones which are like most common. Okay, and then sometimes you might also encounter missing data. Okay, so you might realize that your nightly schedule might have ran successfully, but it would have produced like absolutely no records, and you will be like, I don't know, wondering like why it didn't produce any kind of records. So these are some of the challenges, which is inconsistent formatting, and then one is missing data whenever you're dealing with file sources. And then moving on again. Again, one more most common source you'll see, especially in this modern digital era, is streaming systems. And honestly, actually, streaming systems are like really super fun to work with, and they will test your knowledge to the limits. And these are kind of my personal favorite, and especially I have learned a lot of knowledge, whatever I know, whenever I was dealing with the streaming systems, guys. And yeah, they will actually they will test the limits of your knowledge, and then they will always push you to be a better engineer and always learn, and become the better version of yourself. And yeah, and I really like working with streaming systems whenever I get a chance. And then most common, if you have to talk about the most common examples of them, would be, for example, everyone knows Kafka, and of course Kinesis from AWS, and also of course if we talk about like Azure, it will be event hubs as well. Yeah, so these are some of the examples, and then here the characteristics of streaming systems is basically high frequency. So like they will be like pushing the data in like super high frequency, like every second or every minute, or every 30 seconds or every 10 seconds, 5 seconds and stuff like that. And then other characteristics, other characteristic would be it's continuously flowing data. And then if we talk about the challenges, it's mainly actually ordering the data, and then of course idempotency. Yeah, you might be wondering why does Harsha is just saying like idempotency is the challenge only in streaming systems, right? No, it's not just in streaming systems. This is actually one of the most common challenge for streaming systems, but um, I'm not saying it's not the challenge while dealing with other kind of sources. It's also the huge challenge, and you always should design for idempotency, and you should ensure that there are not like any duplicates. And once you run the job with same input, it should always give the same output. So you should always design for that. Okay, not just in case of streaming systems, but also in case of all the other common the source types that we talked about, like operational databases, SaaS applications, files, or streaming systems. It can be anything. You should always design for idempotency. Okay, and then moving on, you will of course also see some niche sources like IoT, Edge, or just logs, um, clickstream. Yeah, so Yeah, maybe let's not talk about let's not talk about the examples and characteristics and um, challenges for these ones. Yeah, they are kind of common data sources, but also not as common as, let's say, like operational databases or SaaS applications or files or streaming systems. So I would say 90% of the time, 90% or probably at least 70 to 80% of the time, you will end up dealing with operational databases and files. And maybe 10 to 15% of the time you will end up dealing with streaming systems, and then maybe 5% or maybe 10% of the time you'll end up dealing with API based sources or SaaS applications and stuff like that. Yeah, so yeah, those are actually some of the most common data sources. And it's really I think actually it will really help you if you kind of understand what are the common source types, what are the examples for them, and what are the characteristics of those kind of sources, and what are the challenges involved when you are planning to like make a design or develop a data pipeline which kind of connects to the source and then acquires the data and then move and then store it to the landing zone in your data platform. Okay, so yeah, and then actually, if you look at the table, I would say the key takeaway from this is simple. Maybe not that simple, but a little bit simple. So I would say there is no one single ingestion strategy. You might have already understood that by now, right? So there is the right strategy. There is only the right strategy based on the source and your business expectations. Okay. So you should always keep your business expectations on top of your mind, and of course, you should also know how to map your business to the source. For example, you should know like what kind of business events actually trigger the data generation inside the source. Okay, so you should know that process better. Okay, and then I'm repeating again, there is no one single simple ingestion strategy for you to pick. Okay, there is only the right ingestion strategy based on the data source that you are dealing with, and then your business expectations and constraints. Okay, so yeah, you should always keep that in mind. At least I think that. And let's now understand maybe like why ingestion matters and why you kind of need to think about ingestion. And then why I'm saying, for example, there is no simple single strategy. There is always your expectations, and and you need to there is your expectations and there is data source, and then you kind of need to try to make or frame a right strategy for them. Okay, and then for the same thing, let's try to understand why ingestion matters. Of course, I think everyone know that if I ask you the question why ingestion matters because we need data. Of course, we need data, and why do we need data? Because we need data in order to enable data-driven decision making, right? Data-driven decision making, and who will make the decision? Business people will make the decision. And why they will make the decision? They will make the decision, in order to improve companies' revenue, right? Profits. Okay, and how they will do that? They will do that by making strategic decisions about products and processes. Yeah, I would say, okay, this is the goal, guys. You should always keep it in mind. Okay, this is one of the reason why ingestion matters. Okay, but then I will now tell you why the thinking behind ingestion matters. Okay, before you start developing any code, I'm saying like you should kind of think, and then you should kind of understand what kind of source system you are dealing with, and then what are the characteristics of that source system, and then what are the challenges involved in that source system. So I'm saying you should think about all this, right? And then I'm also saying like you should always have your business goals or business expectations and constraints in mind, and of course cost is always there. So now let's maybe understand, yeah, why the thinking behind ingestion matters. Like let's say there is an e-commerce company like Amazon or Flipkart. Now let's say that there is an e-commerce company, and then let's say that e-commerce company is kind of processing let's say 2 million events. Okay, 2 million events is like, I don't know, maybe this much. Okay, let's say that company is processing 2 million events per day. Okay, and then what happens if they ingest the data once per day? Okay, so if they want to ingest all the 2 million records once in a day, basically whenever we are saying once in a day, so we are implying that we should process all the 2 million rows in a single batch window, right? In single batch window. So if we want to run our job only once, and then it should process 2 million events, in the sense we are implying that it should process all the data in single batch window, right? And in order to process these many events in single batch window, you might require lot of compute and parallelism. Of course, it depends on the technology. Yeah, but generally, you still need a lot of compute and parallelism. Okay, so that's the basic idea, right? But then now let's say you are trying to process this 2 million events maybe like every 1 hour. Okay, let's say you are trying to process 2 million events every 1 hour. So if you are trying to process these 2 million events every 1 hour, then it's like 2 million divided by maybe 24, and which is something like 83,000, right? Approximately. Okay. So if you are trying to, this is one day. So if you have to process 2 million events in one day, then you kind of have to process everything in single batch window. But then if we are saying, okay, you have to process, if you have to divide the 2 million events into 24 hours, which means like every 1 hour you will be processing that data, which is like around 83,000 rows every 1 hour, right? So this is every 1 hour 83,000 rows is, I would say, at least many people will agree that it is more manageable. Okay, more manageable, and you are basically spreading the load throughout the day, right? Instead of processing at only one time of the day, so you are kind of trying to spread the load throughout the day. Okay, and that might be fine for some scenarios. Okay, and let's say if your ingestion runs every 1 minute, what happens if your ingestion runs every 1 minute? Then it's like so then it's like maybe like 24 into 60, so which is like 24 into 60 is basically 14,040, something like that. And then if you are trying to like process 2 million events, and if you are trying to spread that over every one single minute, okay, then you are basically kind of approximately trying to process 1300 events, right? 1300 events or 1300 records or rows per minute, which is nice. This is a little bit more manageable, maybe. So what I want to imply, or what I want to what I want you to take away from this is, So the total volume is not changing. It's still 2 million events in whole day. Okay. But but it's a radically like different system behavior depending on how you are spreading the load. So you should always keep that in mind. And then this is why I'm saying, like, I'm implying that the data ingestion is always tied to the freshness of expectations, and it's not just about the volume. Okay, it's the freshness of expectations. You should always keep that in mind. Okay. And with that being said, let's now move on to our next topic, um, which is naive versus mature ingestion. So till now we talked about what exactly is data ingestion, what are the common examples of data sources that you normally ingest the data from, and we talked about why ingestion matters. And then now let's talk about naive versus mature data ingestion. And then after that we'll move on to key considerations. So I think I probably no, don't want to spend a lot of time talking about like naive versus mature data ingestion. This is more like on the example or on the surface level. Of course, I am going to talk about various ingestion patterns in detail and various ways to ingest the data in more effective way in detail when we probably like finish this data engineering life cycle in detail. So for now, let's maybe touch up on the surface and let's move on to the key considerations. I think I would that would be the most important part of this video. Okay. So for example, let's say you are trying to, let's say in your operational database, there is some table called orders table. Okay. Let's say again, I like e-commerce, and then let's say in e-commerce, what will normally happen is people end up ordering the products, right? So obviously there will be some table called orders table, which will be maintaining all the orders detail. And I'm not talking about like whether it is normalized, denormalized, and all that here. So let's say there is some table called orders table. Okay. So let's say you wrote this query, which is select star from orders. Okay. So if you know a little bit of SQL, now you kind of know that select star from SQL, whenever you run this query, what it will do is it will kind of give out all the data present in that table. Okay. And then what happens if you are trying to extract the data using this query, or acquire the data using this query before you transport it, or before you move it to your storage. Let's say you are trying to run this query to get the data, to collect the data. What happens is that every time you run this query, so it will kind of give out all the data present in the table, right? And orders table is like literally quite huge. I think it will be quite huge, because it's like, imagine like there will be like millions of people who will be ordering the products each and every single day, and obviously the table will be like growing and growing and growing and growing. Okay. So it will be like really huge in size, I would imagine. So so if you try to do select star from orders, so it might work, okay, until it does not, right? Because it will work for maybe some certain period of time, and then it just stops working, because the table, the data volume is just huge to handle. So you need to frame your strategy accordingly. This might be actually fine for day zero loads. um, let's say you are trying to establish a data platform, and you are trying to like get the data, all the historical data which is available in the data platform. Maybe if you try to run this query once and get the data once into your tables, and from day one if you end up doing incremental loads, that might be fine. But yeah, even for day zero as well, you might need to consider some kind of batching logic or something like that. But yeah, let's not talk about that. But what I kind of want to imply is, if you are running this query each and every day in production, it will kind of select all the data which is present in the table, and then you might need like huge compute to, in order to move this data into your data platform storage, right? So this is I would say, this is what I would call naive, right? So you don't want to do that until on day zero, okay? But let's talk about how we would want to do that, okay? How we would want to handle the data ingestion, okay? So what the most, or more, not most, the more, a little bit more, mature data ingestion pipeline, what it will do is it relies on change detection, okay? It relies on change detection, and it will try to process only the incremental records. It will try to do only the incremental loading. So, and how it will do that is, for example, for that query would look maybe something similar to this. So we are still going to select from same orders table, but this time we are going to select only the latest records. And how can we do that? There are different ways to do that, but one of the day would be, let's say, you have a column called updated timestamp. So you always need to select the data from the table, okay, based on the updated column and based on your last ingested timestamp column, okay? So let's say you have ingested data at probably 2 o'clock, okay? Not at 2 o'clock. So you have, let's say you have ingested all the data until 2 o'clock. Let's say until 2 a.m. Now, and then let's say you are running your pipeline again at 3 a.m. Okay, now what you should do is, okay, you should actually read only the data which is loaded after 2 a.m. until 3 a.m. right? So that's what incremental loading is all about, okay? So this is, I would call, little bit more mature than the previous one, okay? So that was more of naive, like selecting all the data from table again and again, and using a lot of compute to move the data. And then in the second case, it's more of an incremental approach, which is just selecting only the incremental data or only the latest data every time, okay? So, and of course, here I'm not talking about all the different strategies, because one thing is, so this is also called as, I'll just touch upon it a little bit, maybe. This is also called as, watermark column based approach, okay? Watermark column based approach. Here, watermark column can be your timestamp, or it can be your primary key column as well, okay? So, yeah. So that's a little bit about the naive and mature data ingestion approaches. Okay, so yeah, and then honestly, the difference between both of them is a little bit simple. So if it is like a naive one, it's like it will read the full data every time, so it is like expensive and slow and not fully reliable. I would say unreliable. And then if it is the matured approach, which is the incremental loading approach, it's like the main motto of the incremental approach is pull only what has been changed till the last time. So that's why it's a little bit more efficient and scalable, and of course like predictable as well. So yeah, now let's try to move on to the final section of this video, which is key considerations. Okay. So now what do I mean by key consideration is, don't be puzzled. Of course, I'll explain what do I mean by key considerations is. So what do I mean by key considerations is, I mean like what are the key things or what are the important things that we need to consider before we start doing any kind of development of ingestion logic, or or before we pick any kind of tool or technology for the ingestion. So we should kind of consider the things that we are going to talk about in a minute. Okay. So the first thing being, so the first thing we need to understand is, why is this data being ingested at all in first place? So we need to understand why is this data being ingested. Yeah. So because again, I'm saying, because in my opinion, intention drives the design. Okay. And examples, if I have to talk about what do I mean by like intention drives the design is, let's say if you are making a fraud detection model, so maybe making the fraud detection model like requires like good data freshness. Okay. So you might need to so for that you that's why you might need to go with streaming. And then if you are, let's say, making some kind of regulatory reporting, so for that data must be complete, right? And so that's why you might choose to go with batch processing with validation. And then let's say if you are making some kind of machine learning feature store, so for that the data should be consistent, right? So that's why you might end up going with incremental loads. So that's what I mean by intention drives the design. So you should always get your intention right, and then you should always understand why this data is being ingested and whom it is going to serve, and then accordingly you need to take on the approach. And then the second one you need to understand is what freshness is acceptable. Okay. The second one is what freshness is acceptable. Okay. So whenever, yeah, this is more like actually latency versus value. Um, and whenever we talk about freshness, there is something called as ingestion lag. So we need to talk about something called as ingestion lag. So what does ingestion lag actually means is, let's say you have a data platform. Okay. So there will be some kind of platform or data arrival time in the platform. And then there will be, data creation time in the source. So ingestion lag is basically the, basically the difference in these two timings. Okay. Ingestion lag is basically platform arrival time minus source creation time. Okay. So that's the ingestion lag. Okay. So when I say what freshness is acceptable, basically how much ingestion lag will you be okay with. Okay. So, and again, this is again not at all a straightforward question to answer. Of course, um, so different use cases tolerate like different ingestion lag. Again, if it is like fraud scoring, you might need the data in seconds. Acceptable delay might be in seconds. And if it is operational dashboards, like then minutes, maybe finance reports, maybe hours, and a regulatory audit or something like that, maybe days. Okay. So so the thing is, nothing is universally real time. Okay. Latency, I would say latency is just a business requirement, and it's not at all like a badge of honor. Okay. So if you are getting the data which is produced in source like a minute back, and if you are able to immediately get it, so that's well and good. But then if it is not serving any business requirement, then I don't think it would be that useful. Okay. And then the third consideration that we need to talk about is, how will downstream systems consume this data? How will downstream systems consume this data? And who are the downstream systems, whether it is like whether it is a human or actually machine. Okay, so when I say human, I actually mean whether, for example, it is like a I mean whether it is like a BI or analytics teams or stuff like that. And whenever I say like machine, I mean like it's a machine learning model or some SaaS application or AI models and stuff like that. Yeah, and yeah, if it is human, yeah, so it should be basically consistent, and it should be clarity, and the data should have like reliability, and it should be, most important thing, it should be interpretable. Okay, so it should be understandable by the humans. But for machines, so consistency is important, structure is important, and schema stability is important. But but the data model which is designed for humans in mind will look, or for sure it will look completely different from the one which is designed for machines in mind. Okay, and then yeah, again moving on to the moving on to the next important point, which is how does the source behave under load. How does the source system behave under load? So this is again pretty straightforward. So if you are going to query your source system during the business hours, especially when a lot of other customers or users are querying it, then how is it going to behave? So not every source wants to be queried frequently. For example, let's say a Postgres SQL system is there, which is running like ERP transactions. Basically, it should not be like hit with heavy joins during work hours, right? Yeah, and sometimes most often, I would say what end up happening is most of the teams, actually most of the data platforms, they actually don't even get the direct access to the source system. Okay, most of the time they will get access to some kind of replicas. Okay, so a replica will have same kind of data in the source system, but yeah, it's just a replica. Okay, it's not your main system. Okay, but yeah, it will be the data will be copied always, and data will always be, most of the time, depending on the configuration, it will always be in sync. Replica will always be in sync with the source system. Okay, so you might end up getting access to read replicas, or you might just get like snapshots. Yeah, and you might get like access to event logs or stuff like that. Yeah, and yeah, I would say, yeah, if it is like matured organization, I would say most often you actually don't really get access to the direct source. And then again, moving on to the next question, we need to understand about the data format and the structure we are expecting. Yeah, yeah. So what do I mean by data format or structure is whether it is like data can be in different formats. It can be like delimited like CSV, JSON, or Parquet. Yeah, and Avro. Yeah, Avro slash protobuf. Don't worry at all if you don't know all these file formats. We will discuss them in the future videos for sure, or maybe Excel as well. Okay, so what is the data format and structure that we are expecting? Okay, and it's really important for you to know about all these different formats, because it will help you design the data pipelines accordingly. So why I'm saying it will help you to design the data pipelines accordingly means, so there is one philosophy that whenever you are making some kind of code, or whenever you are designing some data pipeline or any kind of logic or anything basically, so you should always plan for failures. Okay, so remember guys, okay, So in perfect world, there should be no errors at all. So in perfect world, there should be no errors, and whole world should be error free and issue free, and everything should run like perfectly. But we know that world is not perfect, and even the systems, so does the systems are not perfect, and we are never going to have like super perfect systems. So only thing we can do is we should always plan for failures and see and try to evolve from it. Okay. So and how do you plan for failures? If you want to plan for failures, you want to so you should try to understand the characteristics of each and everything underneath it. Okay. So so that's why it's really important to understand what kind of challenges or characteristics of each and every type of source or the data format that will help you to plan for failures. Okay. So whenever we are talking about like CSVs, so it's yeah, CSVs are basically, to put it in simple words, they are simple, fragile actually, like super fragile, and they are prone to variations. Okay. And then if I talk about like JSON, most of the time it will be nested. Sometimes it will be like deeply nested. Yeah. And then of course dynamic schemas. It supports dynamic schema. Okay. And then if we talk about Parquet, it's actually super efficient, especially for analytic workloads. So so if you want to do any kind of analytic workloads, this is super efficient. And not just Parquet, like any kind of columnar formats with good compression and indexing. And if we talk about like Avro, yeah, it's actually one of the good features is like it has like super schema governance. Yeah. And then Excel, uh, yeah, to be honest, Excels are like unpredictable, I would say. I might get like a lot of hate for saying this, but yeah, they are like, in my opinion, they are like unpredictable, but they are like super common in the real world, and they are like really easy to use, and that's why like many people use it. Yeah. So again, moving on to the new point, the next most important point, that is, does the data need conditioning? Okay. Does the data need conditioning? Now, what do I mean by conditioning? Okay. So when I say conditioning, basically, when I say conditioning, you need to think whether you need to deduplicate the data. So you need to address if there are any duplicates coming in. You need to kind of have a strategy for addressing those duplicates, and then you need to see if you have to do some kind of timestamp normalization, right? So so if the timestamps in your data, or if the dates are in your data are in like different formats and different time zones, so you should try to see if you have to do some kind of timestamp normalization. And you should also maybe do some kind of you should also maybe think about doing some kind of controlled casing. So maybe, I don't know, like snake casing, or camel casing, or kebab casing, or any kind of casing. And you should always you should always, of course, see if you need to do some kind of basic validation checks. Okay. And then of course, like you should also see if you want to add some kind of metadata, like housekeeping columns, you know just for monitoring or ops or lineage purposes. Okay. Yeah. And then you should again, of course, question, um, where and how will the data land. Okay. Where and how will the data lands. Okay. So you should know whether it will land in raw immutable store or whether it will land in staging layer, and then you will kind of clean up or you will kind of override the staging each and every time you load the new batch, or whether it will be like fully modeled on ingestion itself. So so you should know like where and how the data will land. Okay. And again, yeah, I have tried to touch upon this point a little while ago, and then again, now we'll talk about it as a separate point. So, how will errors, retries, yeah, and schema drift be handled? Should be handled. Okay. So, so if your source is adding new columns or removing some columns or changing the data type of the columns or changing the position of the columns, okay, then how will you handle it? Okay. And then if there are like any errors coming in from the source in the data, then how will you handle it? If you are not able to reach the source, then how will you do the retries and all that stuff? So you should have, you should have proper strategy. And then normally thing is like good data ingestion design or data pipeline design assumes failures and evolves from the failures gracefully. Okay. And whenever we talk about errors or retries or schema drift, some of other things that we also talk about in this section should be, idempotency. I have also talked about idempotency in the starting of the video, but yeah, it's mainly about if you pass in the same input, so it should always generate the same output. Okay, it should not create like any kind of duplicates or stuff like that. So idempotency and checkpointing, okay, and dead letter queues, yeah. So don't worry if you don't know what dead letter queues or checkpointing means. We'll of course understand all of them. Yeah, and then of course you should also focus on observability. And when we say observability, there are like mostly 3 points involved in it, which is logging and metrics and lineage. Yeah. So yeah, and so these are some of the most important things we need to consider. So we need to consider why this data is being ingested, what freshness is acceptable, how will how will the downstream systems consume this data, and how does the source behave under load. And we should also, of course, pay attention to the data format and structure, and we should also put a lot of thought behind data conditioning, whether data needs any conditioning, and we should also of course understand where and how does this data will land, and we should have strategy for handling retries and errors and schema drift. Okay. So so that is it. And in short, okay, if you ask me like what does a good data ingestion pipeline look like, so I would answer that by saying like a good ingestion layer feels like predictable, quite observable, scalable, reusable, and boringly reliable. Okay. Yeah. And then thing is, yeah, again, if you don't understand some of the words or some of the terminology that we have used as part of this video, it's totally fine. Okay, stay tuned. We are obviously going to talk about all these different terminology and different words, and we are going to talk about in proper more detailed and practical and way in upcoming videos. Until then, please stay tuned. And one more thing I want to say is ingestion is nothing glorious. It's just like foundational, and it's really important to put a lot of thought behind how you do the ingestion logic, or how you frame your or approach your ingestion logic, because it shapes your storage, and then it shapes downstream architecture, and it shapes the trust in the platform. Okay. So and thing is, tools will change over the time and patterns will evolve, and but the mindset behind good ingestion should always be timeless. Okay, always remember that. So today you might be working in Snowflake, but if you switch to other company, you might be working in like Databricks, or if you go to other company, you might be working in like Microsoft Fabric. If you go to maybe not other company, if you go to different team in other company, you might be working on like on-prem as well, and that's fine. Okay, so that's why I'm saying like tools will change and patterns will evolve, but the mindset behind good ingestion should always remain timeless. Okay, and yeah, if you feel like if this video helped you understand ingestion more deeply and practically, please like this video and subscribe, and please share it with your colleagues and tell me in comments. Actually, I'm really curious to hear from you guys. Are you actually using batch ingestion or streaming or CDC file imports, or mix of everything? Like I'm really curious to hear from you. And in the upcoming video, we are going to talk about streaming versus batch ingestion, and then we will also touch up a little bit upon push versus pull ingestion patterns. And until then, stay tuned, and thank you so much for watching this video, and good night, and see you.